This is the MathMap Book Club, where ordinary parents encourage one another to develop an extraordinary appreciation of math. We love what we know and struggle over the unfamiliar. Through weekly conversation and exploration among friends, we can begin to enjoy ideas that seem difficult. Join our book club as we discover how math helps us to know God and to make Him known.
Hi, I'm Lee Bortons, and it's Wednesday, September 27th, 2023. Welcome to the MathMap Book Club, where Kirsty Gilpin and I discuss a math concept each week from our soon-to-be-released curriculum for families with students in classical conversations communities. And Kirsty's on the road today, so she's in two places at once. She's here inside of her machine while she has someone drive her. So if we have some technical difficulties, we'll just step in and help out. But thank you, Kirsty, for making this extra effort while you're headed towards vacation.
Oh, I'm glad that I can do it. It's one of those blessings of technology. We can sometimes, so share screen ahead.
Okay, you're struggling. It's kind of struggling. You want to try again? My understanding is Babs or Jill, one of you is ready to take over. You're like, what? Not us?
We are. We're certainly ready to talk and to, be a little impromptu with you.
Okay, so I will do that. All right, so Kirsty, if you make it back in, please just barge in, let us know you're here. So this week we're talking about locations. It's lesson 21 in the math. And Christine, if you can go on to the next slide. So our exordium, the thing that we open up our sessions where we tutor with our students and during the pilots and then the upcoming challenge years, is always a beautiful piece of art with a quotation. I realize I've been saying quote all these years. It's actually a quotation and a reflection. And I know Kirsty was hoping that we would talk about the quotation today. So I'm going to make my screen bigger and then read it to you. Man's mind, once stretched by a new idea, never regains its original dimensions. From Oliver Wendell Holmes, a famous person during the early 1900s in the United States. So, gals, what do you think is being stretched by going through the math map?
I would counter what is not being stretched. I think there's so many math concepts that we learn through going through the math map, and not just math concepts, but just like how to think, which I guess is just a classical way of learning anyway. But I feel like we don't always incorporate that into our math studies. So it's been interesting to kind of model that for the students of how we can learn through asking questions and through looking at an answer key and working backwards. So I feel like there's just so many things that we're learning. They're not necessarily math computations, but just like how we're learning math concepts or just concepts in general.
So I heard you just say that if you use the answer key, you're not a cheater. But that's actually what lifelong learners use to get them to the next step. How would you, because you don't want your brain to go back to its original dimension. So what's the difference between a student who is using it to cheat, just I get my work done faster if I go look at the key, versus the student who's using it to struggle? How do we help identify how their brain's being stretched?
I think a student who's using it to cheat is not, in fact, they're doing the opposite of stretching. They are shrinking. And not only are they shrinking in their knowledge, but they're shrinking in their confidence. They're shrinking in their character. They're shrinking in what they believe about themselves. They're shrinking in their relationships to their parents, their fellow students, their tutor, to the Lord. It is a dangerous and very unhealthy practice. And I think that if we can, hopefully sharing with students that you are allowed to use the answer key takes away the hidden part or the guilt when it is a valid use. But if a student is just using it with the intent of cheating, then we need to know about that. And that's one thing where doing any kind of work off in the corner and not in the same room as the parent can make that more possible. And even telling them, sometimes they might feel that they're cheating, but really they need to copy. And so what's the difference in cheating and copying?
Yeah. So that's one of the reasons the solutions is in the middle of the booklet, because there's probably times where you're going to say, child, I'm going to help you govern yourself right now. And I need you to spend a half hour on this before we look at the solutions. But there's other times you may go for it. This is all hard. It's all new. I'm not sure how we're going to help each other get through this. The solutions are yours. Right. And that takes assessment on the family's part, because sometimes the child is not good at that, but we want them to one day be good at that kind of assessment for themselves. So good answers, gals. Okay, anybody else? What do you think about this quotation?
So this past Sunday, we were singing a worship song that was new to me. And one of the lines in the verse was talking about the magnitude of God's love. And it just struck me like, okay, all the things I know about magnitude in math, now I'm applying that to the Lord. And so I'm understanding his magnitude in a way that I wouldn't have had I not spent some, like, I was picturing vectors. I'm like, oh, this is really weird, worshiping with vectors middle of service, right? But my mind was changed just by the awareness of how we notate a vector, what a vector means, and then what does that tell us about the Lord? So it was really cool.
Yeah, so for those of us that don't know what you're talking about, on a vector, I can say to somebody that table's 20 feet away, and that's only so helpful. But if I can say that table is to my left 20 feet away, now I've used both a direction and a magnitude. And we use vectors in our language all the time, don't we? Giving directions to our children. It's on top of the table. Move your hand down the bookshelf 1 foot. There's the book I want you to get. So it's not surprising that you're worshiping with them now too, because it's part of the language that he gave us.
Yeah.
Anybody else? Kirsty, are you back on yet? I can't tell.
I am, and I just had this image. This is a new idea. I'm going to try but I just had this image of a balloon. And sometimes when we think of learning or we're reading a book, we want to understand everything right at once, right? And remember all of that grammar. And our brain is stretched out to hold all of that. And then we go about life and we lose some of it, right? It doesn't all stay the first time. But I was thinking about that balloon, that I blew it up once and then I let the air out and it zooms all over the house, right? And it's really fun. But when I pick it up, it didn't go back to its original size. It's a little wrinkly, it's a little stretched. And so the next time I go to blow it up, it's easier to blow up. It's easier to get that air in. And it just was an analogy suddenly to me of our learning, that sometimes when we learn, we don't get it all the first time, but the struggling stretches us out and makes it easier to learn the next time we see it. And that's the difference between the familiar and the unfamiliar, is that when it's unfamiliar, it's that initial stretching, so that when we come back, we go, oh, this doesn't seem as bad this time.
I think all the new brain research just is proving that the brains, they use the word plasticity. And so men who were injured in battle, who were quadriplegics, are now walking again, because they realized the brain is plastic. It can be stretched, but it's hard to do it. And so when we see those miraculous kind of things occur, it makes me think, okay, my kid can struggle a little bit with a problem he doesn't like or a challenge that he's not interested in, because we know that the brain will eventually accept it and say, yeah, I'm actually enjoying this and it's good for me. Great. I love the balloon. Okay, so you want to go on to the next page, Kirsty?
Yes, I think we're ready.
I'll let you lead until you can't.
Okay. So as we look at our math map this week, and we talk about, we always try to talk a little bit about the math map and the language and the order of mathematics. We're talking about location, and if you look at mathematics, a lot of the times we use the word locus, and when you see the lines, especially in their fullness, we use the word locus. And our title is location. Because that's a more familiar.
Oh, bummer.
How can the English word location illuminate our understanding, but how might it hinder our understanding? Does anybody want to jump in and talk about, and we can think, but you can think of other words that when they're translated, sometimes it helps and sometimes it makes things a little bit more difficult.
Well, you know how when you are reading different translations of the Bible, and there's different ways that people have translated them into different words. And so I feel like sometimes if they're translated by different people and there's different understanding, I don't think it always helps. Because sometimes I feel like they've added things to the translation that maybe weren't necessarily supposed to be in there. And the main one I think of, which hopefully I'm not going to hurt anybody's feelings, is the Message Bible, because I just can't wrap my head around reading that. I guess if I wanted to read a story, I could read it. But if I actually wanted to know what the Bible was translated, I wouldn't use that. But more so, I was thinking about, this might not be what you're looking for, but I was thinking about vocabulary. And the reason I thought about vocabulary is because I was tutoring a student earlier this week, and we were reading something, and there were a couple of words she didn't know. So we looked them up in the dictionary, and I can't remember what words we were looking up, but the word meant conquer, or conquer. And she said, well, why didn't they just say conquer? And so I think, sometimes the vocabulary hinders us. And especially a young student, if the vocabulary is too hard for them to understand, or they don't know the vocabulary, they just stop. Have you tried to read a book that was just so high level and you're like, I just can't read this anymore, like I need to take a break? So I think that could hinder our understanding, because we might stop reading it. And if we don't know the words, we either have to look them up or we guess what we think they mean by context in the sentence. So that could hinder the way we understand it.
We also tend to use the word location in a generally precise way, kind of like it did in my other example. And so maybe a good way to show the difference between location and locus would be to say to your child, all right, you're 16, you're learning to drive, you only have $5 worth of gas. In any direction, how far could you go? Well, that of course then is a circle. Are you following? Well, that circle now is the locus. It's all the locations that meet the $5 restriction. It's right. So you give them a condition, and the range of all the many answers is the locus. It's not a single point necessarily. It can be, but it doesn't have to.
It's a great example, Lee, of comparing where we use that word location a little bit differently in English to the way we use locus when we're thinking about it mathematically. And so we just need to be careful with our students. We talked about this last week or the week before about using the specific words, that sometimes it's helpful to give our students an English word, a more familiar word for them to build their understanding on. But then it's also really wise for us to then transition to the specific word that we mean, and help them to build on that peg when we do that.
I have a
Great,
question for
great discussion.
everybody. Oh, good. I have a question for everybody that's related but not. When you see that word location, and if you're not really don't like math, is that helpful to say that you're going to study locations? Or what if we had called 21 locuses? With John the Baptist, right?
Right. I agree that using the word locations is a great introduction to a math concept using a word they're familiar with. And I think that one of the things Kirsty let us in with some of our MathMap tutor pilot conversations was that we can narrow what something geographically. We can say it's on the planet, it's in North America, it's in the US, it's in North Carolina, it's here in Charlotte or Pinehurst or wherever. And so narrowing, it's a little bit like narrowing the domains that we've done before, where we can, it's a complex number, it's an integer, it's a natural, it's a digit, those kinds of things, or even in the room, how precise we can get. It's an easier, well, not easier, it is a more hospitable invitation to how we can define things more and more closely. So those kinds of connections have helped a lot in my experience.
Anybody else?
Well, I was wanting to ask a clarifying question because I'm not sure I understand the difference clearly. So are we saying that in math, the word locus is referring to all of the individual locations that would make like an equation true or make something true? Or what does it mean?
So when we think, usually we think of a locus geometrically to describe sets of points, right? So they are locations that are, you know, we may be able to pick precise locations if we have a coordinate plane. But in the example of a circle, for example, I can describe the circle as the set of points that are equally distant from a center point. And so it's that set of points is the locus. I'm describing it with words and saying all the points that meet this condition. And so it is a, right, it is my plane, it does depend on, but it,
We lost you.
Set of points.
Carrie, did that help?
The set points that are equally
I think
distant
so.
from endpoints in a segment.
I think I'm also confusing locus and focus because I've seen focus on circles and ellipses.
Yes, a focus is a specific point. Is a
Okay,
specific point that helps to build that and define a parabola or a hyperbola. But the locus is the shape itself.
okay,
Does that help?
it does.
You want to go to the
Can a
next slide?
locus, I was like, go ahead, that's fine.
Well, go ahead, ask your question while we're waiting
I was
for
gonna
the
say-
slide to come up.
Can a locus be a point?
Yes.
Okay. So it can be a point or a line or a shape.
Yes.
Okay,
So using our geographic, right, I could say, what is the locus of that is defined between 75 degrees west and 76 degrees west, right? And it might, and that would be a whole band of locations around the globe. I could say, what's the locus of points that are just at 75 degrees west? And now it's just that line. It's just things that are exactly at 75, right, along that line. But then I could say, what's the locus of points that are 75 degrees west and 38 degrees north? And now there's just one point that satisfies all of those criteria. So that's the idea, that I can have, it's giving some kind of criteria and it's the set of points that satisfy that criteria. And but we're usually thinking of it geometrically.
So if you said, I want 35 degrees off the meridian versus I want 35 degrees off the meridian and it's also on the equator, those extra
Yes.
conditions limit and limit and limit your answers.
Yes.
Thank you.
So just a reminder that we are in 3D and we're calling that human space. And that's why we're talking about locations, because it is a mathematical idea, but it's important for us to understand where we are, right? And how do we know where we are? And how do we know where we are physically? How do we know where we are spiritually, right? What are the things that we can use to judge our location? And so that's why we called this lesson location, because we really wanted to emphasize the applicability of this lesson to us in our human space, right? Knowing where we are. All right. And so we can go to the next slide, Christine, and we'll talk about a couple of specific ideas. So along the top, I've got two different ideas on this slide to talk about. One is from chart 21.2 and the other is from chart 21.4. So the 4 pages of charts in each lesson. And
We lost her.
that the description of Locus have changed their dimensions. Notice it's 1D, 2D, and 3D, and it's describing it as the set of points, a given distance from a given point. And so take a look at those images, and what does the circumstance, right? How is the circumstance of dimension important when we're talking about a locus?
Well, once again, it's limited. You're kind of the examples that you gave on the globe. If you're talking about, if you're only allowed to use one dimension, your locus is going to be just a point, right?
It can be 2
Add a
points.
second dimension, you can have, go ahead.
Oh, it just in this case, it could be 2 points, but it also could be 1.
Okay, right. But then when you add a second dimension, now it's like your limits have expanded kind of in a way.
Now you're connecting the points in the circle. Because you can. We could have made it into a box or square, right? And run through the same 2 points. Good. Keep going, Janice. What's next?
Well, and then so you add the third dimension, and now it's you have more points you can connect, because I don't have the words for this. Like a basketball now instead of a hula hoop.
That third dimension is really important because you don't know what you're looking at a slice of in 2D. You could be looking at a paper towel tube and that it, tapped in ink, and now you just have a circle, but it's open on both ends. And so that the extra drawing in 3D and letting us know that we're looking at a sphere, and with a point, you wouldn't know if you're looking at the tangent of a circle, just where it touched at one point. And if you slid that through more and more, is the circle might be this wide, but that might be that the circle's only this far through. As you go, it's wide. So yeah, each dimension that we add helps us to understand more fully what it is we're looking at.
That reminds me of our conversation last week when we looked at the cross section of a cone, and the certain way it was a circle, which could be the cross section of a sphere. But when we add that third dimension, like you said, we could see, oh no, this is a completely different thing.
Yeah, so 1D could have been a cone, 2D could have been a cone, but 3D goes, nope, wrong guess, it was a sphere.
I think that always pulls back to spiritual truth. that we think we know what we're doing or what we're looking at, but God is outside of that dimension and he might be saying, nope, that's not what that is at all. It's something bigger and better than you could ever imagine. Or it might be something you need to correct or deal with, but we only see a slice of it.
So Jill and Jana, take this thought and go the other direction, right? So the same locus, the thing that's equally distant, right? It's just 2 points in 1D. It's a circle in 2D. It's a sphere in 3D. What would it look like in 4D?
Well, doesn't a midpoint,
What do you think?
so each dimension,
That's good, Jill, because it would still have some sort of center point to it. That won't go
Right.
away.
yeah, but each dimension adds, okay, this is a word I learned because of MathMap. It's orthogonal, which means it's at 90 degrees to the previous dimension. So our x-axis, our y-axis, and then our z-axis, we're adding. And in my mind, I have no idea where to put a right angle fourth dimension.
That's the hard thing. But so looking at this, right, in 1D, this is hard to picture, but looking at this, do we expect that we would have measurable angles in 4D, or do we expect that somehow it's going to be a smooth curve in 4D?
Oh, I see. Well, I would expect it to continue curving because I would
You
expect
mean the
to continue
sphere
curving.
itself?
Well, the locus in 4D, that set of points that are equally distant from a center point, if we were considering that in 4D, right, we'd have that center point. And then what would it, I mean, we can't picture what it looks like, right? We know that, but is it going to look like the tesseract or with angles, or is it going to look like a hypersphere that's still somehow curved?
Could it not have both? We have a sphere and we have a cube. Why can't 4D have a sphere-like object and a cube-like object?
Well, it can, I would agree, right? But I'm just saying this particular locus, right? What do we expect this particular locus to look like? The
So
set of
this one I
points that
would
are
expect to be sphere-like because it's been round. I mean,
Yep.
if you just look at 1D, it could go either way in 2D. But once you get the 2D and the 3D, you have a set idea of what it will be. So in 4D, it would still have that cylindrical or circle shape, arcs instead of straight lines. But your locus to that line from the midpoint or the middle to an edge is still going to be a straight line.
So
Right.
can I?
Yeah, our radius. Yeah. Go ahead.
Yeah, so because I'm getting kind of stuck, we have this length, right? So it's like, I'm wanting to spin it.
Well, that's exactly what you're doing,
Okay,
right?
Wow.
So that's exactly, I've got a string and I spin it, but if I'm just looking at 1D, right, I can basically like zip it back and forth between the 2 points, and those 2 points are the points that are that distance away. Then when I
Okay.
have a 2D, right, it'd be like spinning it on a table, right? And so it's staying in the same plane, and I'm going to get a circle. And then if I'm in 3D, I can like whip it around all the directions. And so now I'm getting that sphere. And then what would that look like if I could go in the fourth dimension? And this is just a great example where we can use these ideas of patterns and use things we know to catch a glimpse of what the fourth dimension, some characteristics that have to be true about the fourth dimension, right? So I know that there has to be a center point, and if I'm talking about everything being equally distant, right, I know I'm not going to have any angles, because as soon as I have angles, some points are farther away than others. And so now I know that it's got to somehow keep this circular spherical shape, whatever that looks like in 4D. I can start using this locus and these patterns to catch that glimpse of 4D. That's just what I wanted to just really encourage us to look at, is how that same description, is giving us different images depending on the dimension that we're talking about, and how important it is for us to be specific. Right, because
I want to say when I was going over this in when I taught challenge, one of my students said, "Mrs. Bortons, math gives me mind over matter," because we were working on vectors and matrices. And you could see in 1D you had an X coordinate, and in 2D an XY, and 3D an XYZ, and 4D an XYZW, and 5D a UVWXYZ. He could add coordinate after coordinate and do the math calculations on a piece of paper for things he could not see in his mind. And that was just, I mean, he went on to study math in college because of that.
so I noticed that we're getting kind of close on time. I mean, we have time left, but we have other things to talk about. So
Good.
just giving people just a couple of minutes. Why do you think we include time in the study of location? Lee and I both just really like this graphic of time, so that's why I shared it with you. But why do you think we include it here?
I think it makes perfect sense when we consider that we've been teaching a timeline to foundations from the very beginning, that there is an idea that it extends and that we can, where we are in time is a location.
And I read from some other weeks in the MathMap, well, it might be this week. I don't remember exactly where it is, but that time is considered like a dimensional bridge, and it helps us connect from one dimension to another. So it would help connect locations, which just what Jill said too. And that graphic on the bottom is so much fun to go over in seminar. The kids love it. Their minds are blown with all the different ways that time really exists.
That was Kirsty's idea. Good.
Does anybody know the history of navigation and what key idea
No.
was, or what the thing was invented or perfected that really allowed better navigation?
A watch that would work on a ship.
Yes.
Timepiece, a
Yeah,
chronometer.
Yep, a decent chronometer, right? Being able to keep an accurate time was what let people navigate well, by knowing the time. And so as we've gotten more accurate timekeeping, we can have actually more accurate locations. And even in our modern day navigation, if you look at GPS, it's all about the time, right? How long does the signal go? And they measure the time between the signal going to a satellite and back in order to figure out, right, where am I? So, all right, we have a new slide next that we're excited to share with you. And this is our release schedule. And you will see there, it starts next year, 2024, and goes through 2029. And demonstrates to you which lesson, which domains, which levels are being released each year. And so the white boxes, that means there's nothing being released that year. The lightly shaded boxes are digital releases. And those will be similar to the Naturals beta that are online now. They'll have the cover, the contribution to the conversation, the lesson pages, and the solutions. And then the solid color is when the printed versions will be available for sale for people to use at home. So for all of those families who are excited to get started, there will be multiple levels available next year and pathways for you to begin at those levels and then move to towards complex if you're not in complex yet. So we're really excited about that. Practicum for the next 2 years is going to focus on logic, and we're going to be really emphasizing the idea of dimension and then domain. And also beginning next summer, all families who are members of CC Connected will have access to the MathMap companion. And I will just let you know that is still in development. There's a lot of content that will be in there, but that is a multiple year project until that is really finished. But all families will have access to that next year. And we will also be releasing 2 new decks of flashcards, and those are going to be notations flashcards and fractions flashcards. So we're really excited at the things that we will be releasing for CC families in just a few months. So,
Finally, it's here.
yes. Although really, Lee, I think it's almost really miraculous that we've gotten it done this quickly.
I hope so. I thought 6 years is a long time, but we've got all, like you can see, really quickly, like we're nearing the finish line. So it won't take 6 more years to get them all out or written, but it'll take 6 years to get them out because we don't want to overwhelm our families and make them feel like they need to do things they're not ready to do. So we'll take our time.
And the MathMap companion, is that kind of like a guide? Is that like, does it have the charts in it and the?
So it will be, it is digital because there's a lot of content in there. And it has, essentially imagine if you could open up your booklet and then stick your finger on something and have somebody explain it to you, whether that's a chart page or one of the exercises, whatever it is on that page. If you're like, well, I just don't understand this, and you click on that on the screen, and on the right-hand side, explanation pops up. And that may take the form of a video explanation. It may take the form of a worked problem, like an explained problem. It may take the form of the exciting idea that takes us further. But that's the best way I can think of it is if you opened up a booklet, stick your finger on the page, you're going to be able to do that digitally.
Awesome.
And just, you know, when you get the print version, the charts will be included in that. We just didn't want the charts online because it's kind of the secret sauce and where we're going for the long run. We wanted to make sure that people were appreciating it and not just passing it out before we could really explain what it is.
And the charts are the same each year, right?
Yeah.
Yeah.
That's correct. Yeah.
Mm-hmm.
All right, Christine, if you want to go to our last slide, then we'll see what we can squeeze in the next 8 minutes. All right, so I chose this page here, again, from our naturals level, because that's really what our book club is on these naturals pages. So let's pick one of these, and we can either talk about the top one. So let's start there. That may seem like something that is hard for our students, but notice that we just talked about these on the chart. So I'm going to pick this here because hopefully it feels familiar to you. And how does repetition, so thinking about our 5-year-old that are working through this exercise and they're tracing what looks like it's algebra, and we're like, why are 5-year-olds doing that? How does repetition build familiarity? How does them tracing this prepare them for working through algebra problems when they're in high school?
It's less daunting.
Oh, go ahead.
It's less daunting. If I've seen X's and Y's in my math before, then when I see them again, it's okay. I at least know that this isn't a new thing.
And it makes
They've always been
it makes connections between equations and pictures, which didn't happen for me until I started directing challenge.
I always think of repetition sort of forms our understanding, like it shapes our understanding. Like when you memorize scripture, that the way it's put together helps us
think along those lines. Does that make sense? I don't know how to say it, but to me, it shapes how I view the world. So I've repeated something enough, like playing a piano. I can do that without thinking about it, and I've absorbed the form of that piece in a sense that it can be applied or expressed in another, or compared to another way. So I think that's why I think of memorizing is so important, because it does so much more than just what you memorize. It shapes your understanding of things or how you think about things, if that makes sense.
I think it builds a rhythm too. Like if you're reading King James and your children memorize King James, then they begin, when they read Shakespeare, it's a little easier because they understand that rhythm. And when they are copying x squared plus y squared, and then they add a z squared, they begin to notice a rhythm. Maybe they can't articulate it, but they are building some expectation of what might also be there.
There's a lot of benefits to that familiarity, right? You're all just talking about all these ways that helps us. That the goal isn't for them to memorize or understand or internalize x squared plus y squared equals r squared. But if they do this every year, and they're doing this multiple times a year, it becomes familiar. It gives them some patterns, it gives them some connections, so that by the time they've done this for 10 years, they're like, oh yeah, well, I know what that is, right? It's familiar to me. It's become part of my memoria, and some things that I've memorized now, right? They're my pegs that I can hang things on. And so now as a more dialectic learner, look at our images and look at our equations, right? And how many terms are in each equation, and how many dimensions are in each picture?
The first one's 2 dimensions and 2 terms, x and y, and the second one is 3 dimensions and 3 terms, x, y, z.
Right. So even just that, right? There's a pattern there we might start to recognize, just between those, right? So even again, as our memoria builds, we start to go, wait a minute, I'm noticing these things. That's great. So let's take that, because, right, Donna, you just said, well, there's 3 dimensions there, even though it was drawn on a 2D page. So I'm going to skip the middle and go to our last question, because this is one of the most challenging things that we all deal with, right? Is how do we express 3D ideas in 2D images?
It's just a matter of mastering the art of art.
Yeah,
Yeah.
perspective.
It's perspective. It's getting that 2D image on 2D, a 3D image on 2D plate. We have different names for it: perspective, trompe l'oeil, different ways you do it. That's what it is.
It's not easy.
No, it isn't. And I was to say, some kids can see it easier than others. And I have often found that if we do one in 3D and say, okay, this is this part, this is this part, like learning that correlation between the 3D and the 2D, then they can start to see it. But sometimes it takes some repetition of this is a sphere, this is what this is representing on the paper. Like you have to teach them how to see it on paper.
Yeah, I totally agree. And a lot of times our editors have said, why are you asking this question backwards? And I'm like, because if you start with 3D, you can figure out the 2D and the 1D because you're starting with what's familiar. So I think that's great, Carrie. So anytime the children are struggling with this, find something in the room that looks like what you're doing and then try to take it away. And it's such an abstract idea, taking away and adding dimensions, that you may find they're very good at it in some places, and other places their eyeballs just are not seeing what you're seeing, especially for that under 12 group where their myelin sheathing isn't totally formed and their brain development's not all there for eye coordination. They may literally not see a 3D thing there at all. They may just say you're crazy.
And you can do 3D shapes, still lifes. Like those are, I've done those, like we just throw them on the table and like, okay, draw them. Like, what do they look like when you try to draw them? It's fun.
That goes back to our foundations oils, right? Okay, don't think about it as being the whole thing, but what do you see? And helping to break it down into pictures. So, well, some great conversation today on a subject that is challenging. So I just want to encourage you all that yes, this is a challenging lesson. The idea of loci, locus and loci is a challenging one, and you all, I think, did a great job. So next week, if you want to show the last slide, Christine, next week is our last week in 3D. Notice we spent a lot of time in 2D, right, where we can master it and we can see it, and we're spending less time in each of the successive dimensions. But next week, we're going to be talking about populations. And I think that you will find it to be a little bit more restful than talking about loci. But I look forward to seeing you all then, and have a great week.
Thanks, everybody. Thanks, Kirsty.
Thank you.
Thank you.